Hello, welcome. And let's go with, we just finished up 3A previews. Hopefully you've gone through and done the 3A workbook sheets and the 3A practice assignment. And now you're here looking at 3B for the preview assignment. Again, 3B gets the screen. Ooh, 7 questions. This one's going to be a big one. Oh well, such is life. Look at that one. So let's go to the video, go to the tutorial. For how much water do I drink? Now, for this one, we are going to be working with the mean again. When we complete this tutorial, be able to find the average price per unit, discuss the water article and find your average water consumption, and we'll discuss the central limit theorem based on a video and applet. Sounds exciting. So let's see, in the next class you will need to be able to determine and compute a mean. Refer to the resource, mean, mode, and median if needed. And if you need to figure out what the resource is, go back to lesson 0, and there'll be a short video on how to find these resources. So let's go through it. Answer the following questions. The following is a list of 4 brands of bottled water and the price per liter of each brand. Find the average mean cost per liter of the 4 brands, rounded to the nearest penny. So 1 liter of Crystal Geyser is 59 cents. 1 liter of Dasani is $1.19. Evian is 99 cents. And 1 liter of Arrowhead is 69 cents. All right. Now we'll find the means. It means we'll add these all up and divide by how many we have. We have 4 items. So we'll ultimately divide by 4. Okay, now one thing we need to do here is units. These 3 are in cents, and this guy is in dollars. Now I can either change 59 cents to by dividing 100 cents per dollar, or we can change $1 and $1.19 to 119 cents by multiplying the dollar is 100 cents. I am going to do this for a simple reason. It turned a decimal into a whole number versus changing a whole number into decimals. So let's add them up. So 59 cents plus 119 cents, 99 cents, and 69 cents. So why don't you go grab your calculator and add those up for me. Okay, now you should have gotten 346 cents, which equals $3.46. Does that make sense? Let's see, that's almost 1, so you got roughly 2,020 cents here. Yeah, that makes sense. Okay, so 346. Okay, that's around the nearest penny. So let's take 346, divide that by 4, and what do you get? That gives us 86.5 cents, and we'll round that to 87 cents. Okay, they kept decimal. Okay, so average cost of these 4 brands of water is 87 cents, or $0.87. Okay, the following is a list of 3 brands of bottled water and the prices for different size containers. Find the average price per liter. Okay, so okay, 6 liters costs $6.99. So 1 liter should be $6.99 over 6 liters. Which gives us, what's 6.99 over 6? That gives us $1.165 per liter, and we'll round that to 117. Okay. Let's see, part B, Dannon water, 3 liters for $1.99. So $1.99 for 3 liters, which reduces down to per 1 liter, and let's call that $0.66 per liter. Part C. Room here. Price is $122 for 2 liters, which is 0.61 for 1 liter. And find the overall cost, find the average cost per liter overall. Okay, now we need to find these individual ones because one was 6, one was 3, one was 2. So if we try adding all those up, I'm not sure what I would divide it by. But now that we have 1 liter is $1.17, 1 liter is $1.17, 1 liter is 66 cents, and 1 liter is 61 cents, we can find the average. Let's see what that gets us. That gives us 2.44 over 3, or 0.8 $1.13 per liter. So, curiosity, let's give it a try. Let's do 6.99. The cost of them, and divide it by what? Well, 6 plus 3 plus 2 is 11. Now here's a question. Are we going to the same answer? Are we? That's $10.2 for 11 liters, which gives $0.927 for 1 liter. They're not the same. They're not the same. Okay. The whole reason being is when we break it down, and we're basically saying that denominators can just be added up, and that's not really true. So you do need to find the average or the unit price. This is what these people were called. That was a unit price, price for one, and that's what we need for doing averages. Unless, of course, it was 6 liters for $6.99, 6 liters for $1.99, or 6 liters for $1.22. Again, same denominator then. What do we get? Part A, $1.17. Got it. Part B, 66. Yep. Part C, 61. Yep. And Part D was 81 cents per liter, or $0.81. So, yes, 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 and yes. You get that first layout of mine. That would be like taking, which was how we got Part A. That's how we got Part B. Which is how we got Part C, and then saying that the Part D would have been just adding my numerators then adding my denominators, which I'm sure hope all of you realize that is not a valid way of doing fractions. Let's see, review the prompt, enter your response in the box. Check your answer when finished. Determine the average cost per gallon for bottled water. Different stores. All right, now, note for these prices given, they all have the same unit price or per gallon. So to find the average, we can add them up. To find the average would be, because they're all per gallon, let's add this column up. So do that real quick for me. Take a few seconds and add them up. Hopefully you all get 8.05. And the average can basically sum all the x's up about how many. And 1, 2, 3, 4, 1, 2, 3, 4, 5. Divide that by 5. For $1.61 average price per gallon for every 1 gallon. So let's see. $1.61 per gallon. 805 divided by 5, 161 per gallon. Okay, now you have been collecting data on the number of cups of water that you drank daily since the first day of class. Okay, that'll be part of one of the earlier lessons. Make sure your data are up to date and record on a daily water consumption data recording sheet from lesson 1, part A. Bring your personal data recording sheet to the next class. Select modification. Send me a copy of it. And I'll basically consolidate the numbers. Instructor may have asked you to provide information for class in electronic form. If so, you bring your data sheet to class. Remember, there are 8 ounces of water in a cup of water. And the data should be in cups. So if you drink one of those big giant sippy glass thingies, you need to find how many ounces it holds. If it holds 32 ounces, well, that's 4 cups. If it's a pint, that's 2 cups. So hope you're not having recording your data in how many of these big, huge, giant mugs of water I've been drinking. No, don't forget to shift it, or it's converted to cups. Okay. Now it's individual. Calculate the mean number of cups of water that you drink daily. Round to the nearest tenth of a cup. Also record the mean of your notes in your notes so that you will have the information for the next class meeting. Your instructor may have asked you to submit your data and your mean electronically. I drink on average, fill in the number. I drink on average about 5 cups. Okay, so read the article and answer the following questions. Okay. So you need to go on pause, and I need you to basically do a cut, I should say a copy, and then to paste it. Paste in your browser and get this article and read it. So it'll take about 10 minutes, 10 minutes of your time and read the article. It doesn't take that long. I'm going to pause for a while. Okay. Hopefully you've read the article and you have it open on a page. So let's look at the questions. Part A, according to the article, the average person in the United States drinks less than how many ounces of water per day? Let's see. Right here. The average person in the U.S. drinks less than a quart, 32 ounces of water a day. So 32 ounces. write that in here. Part B, the average adult loses more than how many ounces of water every day? Oh, very next sentence. If you drink less than 80 ounces, wait a minute. According to the Mayo Clinic, you lose about 80 ounces through sweating, breathing, and eliminating waste. Translation, go in the bathroom. So 80. Yepper. A person who's 1% dehydrated may have as much as how many percent decrease in brain function? Here's water and brain energy. Studies have shown that if you are only 1% dehydrated, you will likely have a 5% decrease in cognitive functions. Presumably that means brain function. Yep. And what do you consider the most surprising fact in the article? A lot of surprising facts. The one I got was a recommendation that as soon as you wake up, slam down 12 to 16 ounces. Ounces of water. And that's to help, I guess, get things going. So maybe I should stop drinking the 3 cups of coffee and just drink water. Okay. Central limit theory. Alrighty. Let's look at a bowl of peas. If you look closely, the diameter of individual peas vary in size. They're not all the same size. If we want to find the average diameter of the peas, we will measure each one, add up all the measures, and then divide by the number of peas to get the mean. Here's a joke. Does anyone want to volunteer to try this? We don't recommend it. It would take a very long time. Luckily, there's a statistical method that allows us to come very close to finding the average of the entire population with far less work. It is called the central limit theorem. The central limit theorem looks at the behavior of the mean of random samples as a way to estimate the mean of the entire population. Okay. Basically what it's saying is, just say these peas are 150 peas in them. So instead of doing them all, what we'll do is do repetitive samples. So we'll do some sampling of 10, and we'll just do them over and over again 4, 5, 6 times. So you're going to get a number of averages. And what you're going to find diameter, count diameters. As you take your samples, you're going to basically create a dot plot. And what you end up getting is basically a distribution around close to the actual mean is. So you bracket it. All right, let's go on with it. Central limit theory simply states that a graph of the mean of all possible random samples from a population will form a normal curve around the mean of that population. Another way of saying this is that the mean of the means of the sample sets will estimate the entire population of means. The mean of sample is called X bar. The mean of population is called mu. Population is typically use Greek letters. Why samples use regular letters. So the limit theory applies to our bowl of peas. We start with samples of 3 peas in bowl. We can measure these 3 peas, find the average size, plot the average on a graph. We continue to take out samples of 3 peas from the bowl, find their mean, plot them on a graph. Eventually, the graph of the mean will create a normal curve developing around the average size of the peas in the entire population, the whole bowl. That's what we're showing over here. And there's your X bar. Let's move on. Notice distribution is symmetrical about its mean. You may remember studying symmetrical distributions in your previous class. The histograms. Graph normal is called normal curve. Ooh, distribution video. It's 10 minutes long, so I will task you to look at this on your own outside this video. So watch on your own and email me questions. Or call me, or during one of the WebEx sessions. All right. Sampling distribution applet. Now let's experiment with the sampling distribution applet. Until you feel you have a good understanding of this principle, open the left skewed sampling distribution applet. Who's that crunch? Okay, left skewed. Now, note when we talk about skewness, we look at whether it's left skewed or right skewed is where the tail goes off to. Notice we have the bulk is on the right and it trails off to the left, thus left skewed. So let's hold that thought there. Okay, part A, notice the left skewed distribution in the applet. What is the mean of the population? Well, the mean is, fortunately it tells us, 42.9486. Part B, what is the sample size? Let's see what it says here. Oh, guess it's right here. Sample size 2. Sample size 2. Let's see. Click one time. Click one time. What is the meaning of the sample? Okay. So here is the population. And here are the two, sample size 2, here are the 2 items that were picked out of the sample, 2 samples of the population, and these 2 samples average I'll give you this guy. Well, average to, looks like 32.7. Oh, the mean of the sample. Right here, 32.7172. And it's hard to read this. Here we go. 32.712. Part D. Click 5 times. 1, 2, 3, 4, 5. All right. So we took 5 samples of 2. So 5 times. So that's what we're seeing here. 1, 2. Uh-oh. Let's do a reset. There you go. Let's do 5 times now. There's 1. Okay, now it's going to do this 1 time. There's 2, 3, 4, sample, average, 5, average. All right. So now between the first one and the last one we just did, 6 samples, and there is, I guess the means of the means, and now it shows 40.8, which is starting to approach 42.9. Again, 40.88. Notice buttons during 1,000 has been removed. If there was such a button, what would have? What would be the mean of the sample means? What would be the shape of the sample means? Don't know what it'd be, but it'd be much closer to the actual mean. Let's try a couple things. Let's just hit this a few more times. See how it works. We're not going to do 1,000, but let's get up. Let's go. Let's do 20. 1. Let's do another 5. See something come below the mean. Sometimes they go above the mean. So now let's look at it. Did it 21 times, and the mean of the samples is coming at 42.7, 42.9. It doesn't take a lot to get there. .9, 42.9. We increase it for each mean to be 4 samples per average. We should get there a lot quicker. .9, 42.9. So by doing these here small samples repetitively, we do get close, pretty close to the actual, within a certain range of the mean, true mean. All right. Now let's open the right skewed sampling distribution. Again, look at it. It trails off to the right. That's where we get the term right skewed. And again, let's try to change some parameters. What is the mean of the population? Looks like appears to be 5.94. 5.94. Change sample size to 10 and click 1 time. Sample size of 10, click one time. It's going to take 10 samples out of the population. And we get an average of the mean of 4.74. Okay. So a little under. Okay. Click 5 times. Now it's going to do five sampling of 10 samples each, or 5 averages of 10 samples each. And it's on the build distribution. Again, see we have a mean of 5.57, mean of 5.941. So not perfect, but it's pretty close. .5793. Of course, generate 1,000. What would be the mean of the sample mean? I would highly surmise it would be 5.941, and it would be a normal distribution. So let's just do a few more. Not the fastest. Okay, 5.94, 5.54 still. To one more. I guess that'd be 16 then. Well, yeah. All right. So again, basically, we're building a distribution that's going to look something like this. Okay. Means a little low, but as you do this more and more times, it will eventually approach the true mean. All right. This is a long one, a longer. So how confident you can find the mean? Me, I feel very confident. How confident I can find the average price per unit? Well, just divide by how many units there are. How confident you can discuss water article and find your average water consumption? I'm pretty confident. And central limit theory. I'm confident because I use it for a living. However, you may want to work, experiment, continue working on this one. Try to change the reference size. There's a rule of thumb. If you have your data, your samples from a not from a normal distribution, this is not a normal distribution, your sample size should be at least 30 or greater. Let's see, that looks like. Okay, there's one time, second time, third time. Notice how the bigger sample size, the faster it goes in on a mean. Just keep doing lots and lots of these guys. The equivalent of 123 times, 5.8 versus 5.9. We'll play with some more. And with that, I am going to call it complete on the lecture portion of the tutorial.